Hello, students. So today, what I want to talk about is actually on geometrical construction. So the students that I'm teaching right now in school, we are going to start on geometrical construction for secondary two. Uh, why is geometrical construction important? Because to some students it's few years, right? It's just like isolated topic that suddenly you need to learn how to use the compass and the ruler. But actually, geometrical construction, if you understand the history of mathematics, is the foundation of this geometry itself. The entire structure of geometry is based on this geometrical construction. So, why do I say that? Well, at first glance, it seems that it's just drawing lines, and then using the compass, you draw arc, and then you have straight edge. But it's more profound than that. Okay, so let's explore the importance together. So let's talk a bit about the history. To understand why geometrical construction is so important, we need to go back all the way many thousand years ago in ancient Greece. The ancient Greece is a civilization that started to document a lot of things and formalize geometry as a field of study. And one of the most influential figure during that period of time of history that was recorded is actually this mathematician known as Euclid, sometimes also known as the father of geometry. So this Euclid wrote a book called Elements at a period of time, and it's a collection of mathematical principles and proofs that continue to influence mathematics education up till today, right? So at the university level, if you study mathematics as a major, you will definitely go a bit more in depth about what this Euclid has actually accomplished. But what he does is that in his book Elements, one of the things that he did was to start from very fundamental things like what is a point, what is a line, what is an angle, and then after that, what happens when two lines come together, and so on. So from very basic idea, it created the entire field of geometry that we know today, including all the shapes up to 3D shapes and even non-Euclidean later on. That one beyond, it actually extend layer by layer extent. So when we do construction, like drawing lines and drawing arc and measuring lengths and angle, this is where it starts from. We start from the very basic principle of line, angles, and we just go, right? So of course, this video is not meant to go through the entire history and entire elements. It's not meant for that. It's just to for your awareness, so that you know that when we do geometrical construction, it's not all by itself and just learning how to use compass. It is really the building block and the foundation of geometry itself. So what happened? Just to give you an example, right? uh, in the elements, Euclid actually show basic shapes like triangles and circle, and even all the polygons, four-sided shape, five-sided shape, and so on. And he created all these shapes using only compass and the ruler. Now, of course, the ruler, instead of calling a ruler, is the proper word that he used is actually a straight edge. That means for drawing straight line. So we don't actually measure the length of the lines that he draw. So he described lots of things like how to bisect an angle, construct equilateral triangle, and these are just exercises that you can do as well, right? So these are visual proofs to demonstrate all these geometrical principles that is universally accepted. Like we all know when we say equilateral triangle, everybody know what it meant, and because it is constructed in a certain way, it always stays true. Another example is the construction of a perpendicular bisector, right? We talk about right angles. How do we actually properly define right angles? You see? So even the idea and the concept of angles, the degree, which is a unit we use to measure angles most of the time, is also a construct. People actually come up with some ways to measure. But the idea of a right angle predates that because it comes from the idea of perpendicular bisector. And it is not just about drawing lines and creating a logical argument. When we have two arcs, intersecting, and all the points on the bisector is equidistant to the original line segment. Okay, this is something that regardless of how we construct, how much we open up the compass to do the arc, we always create the same perpendicular bisector. And because it's always true, we can be very confident that this principle will hold and we can properly define what is a right angle. So this is perfect, right? So in ancient Greece, they use this kind of technique to really have many applications in terms of making maps, cartography, engineering, and lots of things, because they can start to divide all this distance very accurately. So the Greek actually showed geometrical construction even beyond just mathematics. To them, it actually symbolizes the pursuit of perfection and very grand word. But they really believe that there is an order in the world, and having all these rules by which we can construct all these very basic building blocks of the environment and the world we see in, actually is the foundation that create an entire field of geometry and makes sense of the world for us. So why does it remain essential in today's education system? I think uh, number one, pay homage to history, right? But of course, today with all the tools that we have, we have the protractor and we can get very accurate angles. But to get like 90 degrees or 60 degrees without the protractor, it's not that easy. Okay, but still, by actually having a hands-on learning all the technique of all this creation, recreate all this technique using compass, we get a deeper, innate understanding of how this geometrical concept gel together in a very tangible way. So for example, you construct equilateral triangle with just a compass, it really teaches us, that all the sides are angled equal, because we don't shift the compass, right? We fix the compass a certain length and then we start to draw the arc. It means that the length is universally equal, right? So the angle bisector is same thing. It really helps us to understand how we can divide an angle into equal parts and so on and so forth. Another reason why we want to work on geometrical construction is that it's an exercise in logical reasoning, right? Every construction that we do follows a sequence of steps, and it's a building block building on the previous one. So it actually develops a way of process and method to have a very structured approach to problem solving. For example, right, one of the things that we can construct using just the straight edge, the ruler, and the compass is a regular hexagon, which, right, our school loves using as a very strong symbol for us. So to do that, right, the logical flow is that we create a circle, because any regular polygon, actually the circle is a good starting point, because the circle so all the vertices, they actually land on the circumference of the circle. Then after that, using the radius of the circle, we mark out 6 equal points along the circumference, and when we join them, we form the hexagon. So if we have 5 equal points, we get a pentagon and so on, right? So it's a very it helps us to also relate the concept of circle with the concept of polygons and regular polygons. Amazing, right? So another aspect of geometrical construction is that it strengthens spatial reasoning, the ability to visualize and manipulate shape, right? So it gives us deepen our understanding of the properties of the various shape. And in places like architecture, you use geometrical principle to actually ensure structure stability and so on, right? So a simple construction like having a square inside a circle will make the circle stronger, right? If you just have a circle, you want to reinforce it, you can actually have a polygon object inside. That's just one example. Engineers also often use spatial reasoning to model construct mechanical parts, to see whether the structure actually works using the principles, using ideas like parallel lines and so on. So very fascinating, right? For students, sometimes we use tangent to the circle, to really help us as well, like to really understand deeper the property of circle rather than just something round. Okay, so that's just a lot of examples that we can actually think of. So to link what the idea of geometrical construction from the ancient technique to modern mathematics. So geometrical construction is very ancient technique. Okay, but to link it to today's modern mathematics, a lot of the concept that is derived from this technique still applies to our technology. Like for example, things like the perpendicular bisector, angle bisector, they are still very important tools when it comes to maps. And in modern technology, mapping is, we make use of things like GPS to calculate equidistance between points on a map and so on. So these are very useful stuff. And of course, some of the more artsy stuff like the golden ratio and so on, we can actually reconstruct that using just our geometrical properties, ancient technique that we use in construction. Huh? So the construction that we learn in early geometrical classes, right, is the foundation here. We learn to construct triangles, all the various variants of triangles with different angle properties to help us to understand all these properties as well. And from understanding triangles, we actually deepens our understanding of trigonometric function as well, right? Your sine, cosine, rules, and so on. If we can visualize it and look at it in terms of trying to construct the triangle, it becomes very meaningful. So when we reach that topic, we can talk about it a little bit deeper. And of course, polygons, the idea of inscribed polygons, polygons and circle work together actually help us to understand further mathematics concepts such as calculus and limits. But of course, that one is not for you yet because you're in secondary two. But advanced mathematics that comes into play, right? Very useful stuff. So it's a universal skill, right? The idea of geometrical construction has a bit of exploration and discovery instead of just the teacher, giving you the concept and you just memorize it and try to apply it. There's a sense of exploration. You try it out, hands-on discovery. It also break the momentum a bit. I hope it makes things interesting for you. Sometimes you just on your own using compass create all kinds of different tessellation patterns and what have you, right? You can even use things like the median of triangle to intersect them to see whether they actually meet up at the triangle centroid, and so on. Or you can do circumcenter or circle or triangle. Your triangle, you try if you do all the perpendicular bisector of the each of the edge of the triangle and you find the angle bisector, what properties can you discover? The relationship between circle and triangle. Quite fascinating. Okay. So with that, I hope you had a lot of fun with geometrical construction. Yeah. So it is not beyond just drawing lines and shape. It's a tool for you to explore. So you got a geometrical construction set. You already bought it. You have paper at home. Feel free to do all kinds of things with it, right? And see what you can do. And that is exactly how early mathematician like Euclid actually come up with geometry. He started with a compass and then a straight edge, of course, a very primitive one that he had, and then start to create all kinds of geometrical properties and concept for us that today we are still studying. Okay, so with this, I wish you all the best in learning this chapter. I hope you enjoy it. Have a nice day.